Okay. Right, so we're going to, last time we were looking at differentiation. And really, implicit differentiation represents the last rule that you need to have. So we extended what we did in semester 1 by adding product, quotient, chain, and implicit. And really, with those 4 extra rules, product, quotient, chain, and implicit, you can actually differentiate anything, no matter how complicated it is. So, for example, if I was just to make up some totally random function, ex squared sine log of x plus cos of x all over x sine inverse x. Like, obviously we won't do this, but the point is, no matter how complicated I make it, we can differentiate it. So we see that, okay, well, what rule would we need here? We need quotient and product and chain, and also we'll have to look at a separate side problem to get the derivative of sine inverse x, which we looked at last time as well. So my point is, we actually have all the tools necessary to differentiate anything done. So now we look at integration and some extra tools for integration. And the one we're going to have a look at today is a technique called substitution. And the idea is not so difficult. I'll give you a simple example. So suppose you want to do something like integrate, let's say something like x sine of x squared dx. Now, if you wanted to differentiate that, that's fine. What rules would you need here? You would need the product rule and chain rule. That's fine. Well, what about integrating? Well, the trick here is you use a substitution. So what you do is you say let u equal, and the choice is not always clear, but it's usually what's on the inside. So in that case, it'd be x squared. Then you calculate du dx. So if u equals x squared, du dx would equal 2x. So then that would make the x equal to du over 2x. If I was to rearrange this guy, I could rearrange it so it's like this. dx is du over 2x. Then I go back to my question and start replacing. So this x squared, what does it get replaced by? It gets replaced by u. And the dx, what does it get replaced by? du over 2x. Okay, so let's try that out. So let's integrate x sine u du over 2x. Okay? But obviously something convenient happens here. What can I cancel? I can cancel the x. Also, I can take the 2 out. So I can change this problem into a half integrate sine u. Now that's a lot easier to do. What do I get if I integrate sine u? Plus or minus? Minus cos u plus c. So the last thing I have to do is change my u back into x. So my final answer will be minus a half cos x squared plus c. And that's the final answer there. Now we'll do a couple more examples, so you should write this down as our first example. Are you using one of your questions? They will not always specify the method. Okay.
What happens if it doesn't simplify?
Well then, panic. Panic, yeah. Well, let's have a look at an example. We'll look at one like that in a moment, okay? Can I scroll down? No? On now? Phone, please. Yeah, I know. Wait patiently. Okay. Continue. Am I just waiting for you? Who else needs to write this down? Okay. Right, our next example. So, integrate, let's say, let's keep it similar as our second example. X e x squared dx. Right, what should we let u equal to here, do you think? X squared, good. And du dx? Again, it's similar, it's 2x. So, what does dx equal? D over 2x. Now, we pop that and that back in. So this is integrate x e power u du over 2x. Cancel, cancel, yeah? And this is equal to a half integrate eu du. Well, what's integration of eu? EU. Unchanged. And what did we say the u was? So that's the answer then. Okay, can you write this down? Safra, are you writing this down? Huh? The u? No, I integrate it, so it's gone. Yeah.
Sir, how come you're taking the constant out? Because constant inside the integration should be, when you integrate the constant, it should be x, right? You add an x.
And you integrate the constant?
Yeah, because you're removing the constant half out of the integration, right?
Ah.
Yeah.
Dude, you're confusing me. I integrate it here, and when you integrate, you always write a plus
yeah,
c.
But why did you remove the half out of integration?
Ah!
Yeah.
You don't have to.
Yeah.
I just like to factor it out. If you don't, then you would have c over 2 here.
Yeah.
That's the same thing.
Same.
Because the c represents some unknown constant, and c over 2 is still some unknown constant. Abir, did you write this down? Are you sure? Okay. I know if you have it written down, it's tempting to use your phone. It's just the only problem is when I see people using their phone, I don't know if they have written it down or that they're not writing it down and they're just using their phone. So this is why I'm picking on people. Okay, do we have that? Yeah? Okay. Now, let me give you one that's a little bit trickier to try. So let's say we want to integrate something like bracket 2x plus 3 power 10 dx. And I'll give you a little hint here, although you probably have figured it out. You should make u equal to 2x plus 3. Okay. See if you can integrate this using the technique. Got an answer over there? Yep. So, 1 sec, okay. Do you have an answer? Yeah. Yeah. Okay, let's have a look.
This is a very ugly answer.
Yeah, yeah. You have a fraction over 22. So yeah. Du dx equals 2. So dx du over 2. So this becomes integrate u power 10 d over 2. I'm going to take the half out. So then this becomes a half u 11 over 11 plus c, which is u 11 over 22 plus c, which is finally 2x plus 3, 10 over 22.
11.
Oh, sorry, my bad. 11 plus c. Yeah. Okay, now, yeah. This is number 2 now. Okay.
Doesn't matter at which step we substituted back. Could we instantly substitute back from like U11 from like
The only thing that matters is if you substitute back after, any step after you integrate. So, at any step here, here, or here, after integration I can substitute it.
So we don't have to write 1 over 2u11 over 11 plus c. We could just instantly substitute.
You mean like right here?
Yeah.
You have to. Because you're going to use.
No. Okay. That's okay. I think in the marking scheme they will space it out over 2 lines though. But I don't see anything wrong with it. So if you want to do that, you can. Just be super careful when you're replacing those so quickly that you've got everything right though. It's okay. Yeah?
Would I lose marks if I forgot to write the U as the SD?
If you forgot to write the U,
I left it.
yes, you would lose marks. Yes, you would lose marks. If you don't replace the U with 2x plus 3 at the end, you definitely do. Yeah. You have 2 left, by the way. You have 2 left, by the way. You know what?
Someone got a question on it.
I thought I gave it to both of you, didn't I? Didn't I?
No, I'm the only blind sheep in the class.
Only you! Okay. I'm sorry, I take that back. I thought I gave it to you as well.
It's okay.
I thought I gave it to 2 people.
Concealing.
Was it you?
No.
I think it was just him.
Yeah, well, I'm itching to give it to someone else now, so everybody should be good today anyways.
Maybe it's
Maybe it's Mo.
No.
You do ask a lot of questions.
Yeah, but I ask good questions. I don't ask questions. It's very true.
I'll think about it. Right, I'll give you a tricky one. Are you sure I didn't?
Yeah.
Alright, okay, fine. Alright, no. It's not that I don't trust you, but okay. So we'll have a look at a difficult one now. Let's say 1 minus x over 1 plus x. Now there's 2 difficulties here. It's not clear what you should make the u equal to.
Doesn't matter.
It does matter.
Just substitute.
Well, I at least want to tell you what the u is.
Just leave it up to the imagination.
Alright, fine. Well, I'll tell you what it could be. It's either going to be that, or what's the other choice?
1 over 1 plus x.
Yeah. It's obviously one or the other, right? So, it does actually make a little bit of a difference here, but I think in total, it might not prevent you getting the final answer. But one of these, I think, will be a little bit easier to work with. Okay, but I'll let you try and figure it out. rationalize? No, don't think so. Can only really rationalize when there's a square root though. You know, so if I had something like 1 plus root x, maybe. Tough? No?
Take it 1 minus x is equal to 3. Is it? Yes, it is, because the minus.
That doesn't quite make sense.
Because you get a minus 1,
Yes.
and then you can use that, and then you would cancel out the bottom part.
Mm-hmm.
Right?
Did you get an answer over there? I think a log will appear, yeah.
Yeah, it's log.
You got an answer, Mo?
No.
You in pain?
Go.
Got it?
My mind is both.
Over here? Yay or nay? Nay. Right. Let's have a look at it now. So, anybody have any strong opinions on which of the two it should be? I think mostly these problems work out easier if you choose the denominator. Now, what I'll do is I'll do both. We'll see what happens, okay? But usually a good rule is you choose the denominator. That's not to say it'll be that for every example. I'm just saying, your first attempt should be the denominator. If that fails, then you can try the numerator. Okay? So here, what does du dx equal? And that's nice, because that means dx equals du, which is nice. So this becomes integrate 1 minus x over u du. Now that's okay, but there's a huge problem you realize when you start to look at this. What's the problem? Yeah, the x. The x is still there. It hasn't converted fully or cancelled fully. But that's actually not difficult to fix, because if you just realize that u is 1 plus x, then you can see that x is u minus 1. And then we can replace this with 1 minus u minus 1 over u. Now, of course, we're not finished, but we're on our way. So, what do we get on the top here? We'll get 1 minus minus 1. That's 2 minus u over u du. And I should split that into 2 over u minus
1.
u over u, which of course, yeah, is the 1. So that's integrate 2 over u minus 1 du. Now we can integrate this. What does 2 over u become? 2 log u. Next?
Half constant.
minus u plus c. That's 2 log 1 plus x minus 1 minus x plus c. Now technically you can write the answer like this. 2 log 1 plus x minus x plus c. Can anybody see why I'm allowed to do that?
Plus c.
Well, it's, yeah, what we can say is the minus 1 can be,
It's always constant.
yeah, it can be absorbed into the c. So we're saying there's plus a constant at the end. But I mean, if I said plus a constant or plus a constant minus 1, I mean, it's still plus a constant. So we're perfectly fine to drop the minus 1 if we like. Not necessary, but you can. Now, let's see what happens if we opted for the numerator.
Isn't u 1 plus x?
Isn't it?
Minus
Yeah, but it's minus u. So it's minus 1 minus x. You think it'll work for the other one? Well, let's see. So what does du dx equal here? Minus 1. So that means dx equals minus du. So this becomes integrate u over 1 plus x negative du. So that becomes minus integrate u du over, and now we have to fix 1 plus x. So the same thing as before. I can look here and I can get x is equal to 1 minus u. So this is 1 plus 1 minus u. So that's equal to minus integrate u over 2 minus u du. Now what do I do now? U over 2 minus 1?
Yeah.
Okay.
Just split again.
u over u minus 2 is about as good as I can get with the minus. Okay, so what's next now?
Split.
Split how?
1 minus u over 2.
1 minus u over 2? No. This is not u over u minus 2 over u. Fractions don't split like that.
Oh.
Yeah.
What?
See?
There's nothing you can do to simplify this.
Yeah, that's it.
There's nothing you can do. And the only thing you can do is another substitution. You could say let v equal. Now it'd be kind of stupid to let v equal to u, because you're just literally changing the letter from u to v. So obviously that's stupid. You could let v equal to u minus 2. But you realise, well, actually, that's just u replacing the denominator, which is what we did at the beginning here anyways. So you can continue this way, but you realise if you continue, you're going to do what you would have done here anyways. So this way would be literally twice as long. So this is not the best thing to be doing here. We should substitute the denominator. Okay? So it's really important to realise you have the right substitution at the start before you start, yeah?
Could you give us a question where it's better to substitute the numerator instead of denominator?
Let me think. Okay, maybe I can think of something. I'll just give people a minute to write this down, okay, and then we'll have to think of something. Let's see. Yeah, it's not that bad actually. It's not that bad. Let's take a pen for a second and make up a question here. Angela, I can't think of an example where it is easier to substitute the top instead of the bottom.
So we go for the denominator.
Yeah. Or at least something in the denominator. So I can't really think of one right now.
Thank you.
In the exam, they will sometimes tell you what to substitute and sometimes not. It's about 50-50. So I'll just give you some tips when substituting. So if you had something with brackets and a power, often the thing in the brackets you might want to replace with u. Okay? If you had a fraction where you had a numerator and a denominator, often what's in the denominator you want to substitute. If you had functions like e or sine or cos or log, then usually the thing inside the sine, the cos, the e or the log, you replace. Now, these are just some guidelines, okay? It's not like every situation will be like this.
For the logs,
Yeah.
if you have a constant in front of the log, so it's 2 ln u, then you take u squared.
Oh, if you had a 2,
2 ln yeah, u.
I would leave the 2 out.
Leave it out.
I think so, yeah. Because you don't want to be introducing squares.
Okay.
It might make things more complicated. Let's see. Okay. Let's just do one more difficult example. Yeah?
Just for the last question on the calculator, it says that there is an absolute value.
Yeah. Fair enough. This answer only makes sense if 1 plus x is positive, because you can't take log of a negative one. Okay. Also, if we go back here, we definitely need x to not equal minus 1. Now we have this thing, remember we call them proper and improper. So we don't like integrating and crossing over minus 1. Do you remember that? So for example, if I said to integrate this from minus 1 to 2, or sorry, minus 2 to 2, that's actually quite bad. Why? Because you have to cross x equal minus 1, which would make this 0. Okay? So we definitely need x to not equal minus 1. And we would prefer to stay on one side or the other. So, you know, you would be okay if I said integrate from minus 4 to minus 3. And you'd be okay if we say integrate from 3 to 4. But you're not okay if you have to cross over minus 1. So one way they fix that in the formula book is they put an absolute here. Now, it can be sometimes picky about that. In the exam, they never seem to be too picky about that in the exam, insisting on putting in the absolute. And I think the reason they're not so picky on that is because we don't actually study the absolute in semester 2, that function. We do.
Neither in semester 1.
Neither in semester 1, huh?
The child exam.
Yeah, it's in the Charles exam,
Yeah, child.
but not in the IFY exam. So that's why they're not so picky on the IFY exam. But we'll do this this week in the Charles prep. Okay, I just want to give you one more very difficult one to try. And this one is difficult because the substitution that you might think to use what? Well, x squared plus 4x plus 4. The quadratic, yeah. It's actually not going to help you here. It turns out using that doesn't really simplify. So I'll tell you what substitution to use here. Use x plus 2. See if you can get this one. Yeah. Very good, yeah. Do you want to give this a go? he got the idea over there. The trick is to factorize.
It is phenomenal effect.
Mariam, Rosa, are you working on this? Are you sure? Because you look quite happy, which means you're not really doing maths. Are you doing maths? Are you sure? Yeah.
I know that's my last question. Is it necessary to show what u and du over dx exactly equals to? I understand that we need to show q is what du dx. We need to show what that is.
Instead of what? Just dx?
Yeah.
For simple ones like this, you could just jump straight to the x. That's okay. So what does du dx equal here? 1. So dx equals u. Now this one here, you realize if you factorize it, on the bottom you get what factors? X plus 2 and x plus 2. So that's x plus 2 squared dx. Yeah, which is 1 over u squared du, which is integrate u minus 2 du, which is u minus 1 over minus 1 plus c, which is minus 1 over u plus c, which is minus 1 over x plus 2 plus c. Not so bad, right? Typically a section A question. And like I said, 50-50 chance that they'll give you the substitution. Yeah? Did you write that down? I'll just give you a minute. So once you write that down, you can try these for 10 minutes, and then at 11:50 we'll start the next lesson, which is just, again, continuing with substitution, but for more difficult problems. So everything on that page will be exam suitable.
Sir,
Everything on the page is exam suitable.
is
Yeah.
it okay if I wrote 1 over minus x minus 2?
Yeah.
Yeah, that's fine.
But that's ugly.
Yeah, because I put in the minus 2.
Yeah, that's so ugly.
Yeah.
You have 2 minuses in it.
Yeah.
Yeah. But that is fine. That's fine. Yeah. Yeah. Okay, try these for a few minutes, please. Can I close this? Yes?